Hey there, folks. We're going to talk about some electrochemistry. But before we learn about electrochemistry, we need to know about redox reactions. And what a redox reaction is a type of chemical reaction that involves a transfer of electrons. And it has two half reactions that take place, a reduction and oxidation. And what happens is that the atom being oxidized donates the electrons to the atom being reduced. This causes the atom being reduced to lower or reduce its oxidation number while the atom being oxidized ups its oxidation number. This makes the atom in the reduction reaction the oxidation agent, while the atom in the oxidation reaction the reduction agent. So now we went over redox reactions. We can start with the electrochemistry itself. A key part of electrochemistry is the electrochemical cells. So there are galvanic cells and electrolytic cells. Ooh, that one's kind of hard to say, but galvanic cells are spontaneous reactions, while electrolytic cells are non-spontaneous. So let's first begin with the galvanic cell. And galvanic cells are very common in the fact that they can take the form of simple AA batteries or any battery in a sort, but they also have more simple forms. But besides the point, galvanic cells produce energy using spontaneous reactions, so they are power sources. But looking at a galvanic cell, so let's use the simple galvanic cell right here. This galvanic cell is widely diagrammed or represented in chemistry. It's very simple in a way that there is an anode, a cathode, electrolytes, uh, salt bridge, and an external conductor. So looking inside the galvanic cell, it's pretty simple. You have its electrodes, the anode and the cathode, dipped in its corresponding electrolytes, made out of the parts of the salt and the molecules that make up the anode or the cathode. So what happens is that the cathode gains mass, and while the anode loses mass. The reason this happens is that the anode goes through a oxidation where it sends its electrons through the external conductor to the cathode, where the cathode picks up molecules from its electrolyte solution and collects it. So yeah, and salt bridge plays an important role, like music to a party. If I've ever been invited to one, just never. But anyways, it's like music to a party where it starts and keeps the party going, keeps the energy flowing, but once it's out, then the party's out and the energy's gone. So yeah. Now, if you know what molecules you're using in the galvanic cell, you can actually predict the potential electric energy that the galvanic cell will produce. You just need to know what the half reactions are and which one's the reduction, which one's the oxidation. To do this, you need a reduction or oxidation potential energy chart where they give you the potential energy measured in voltage. So what they give you is the half reactions and the potential energy produced. So what you do is, if you're using a reduction chart, you take the potential energy of the reduction reaction minus the potential energy of the oxidation reaction, and vice versa. And then bada bing, bada boom, you got the potential electric energy produced by the galvanic cell. And now with all this electric potential energy, you can use it to find Gibbs free energy using the equation of delta G equals negative N, which is moles of how many electrons you're using, and Faraday's constant, and the potential electric energy that you just found. And bam. So what you want to usually do is usually measure in kilojoules, but joules is also just fine. So now that we just finished with galvanic cells, we can just move on to electrolytic cells here. So you can usually find these in rechargeable batteries or workshops where you would be trying to separate ions from a molten or aqueous electrolyte. They work just like the galvanic cell, but in reverse, where they do both have a cathode and an anode, but can be put in the same electrolyte with, instead of producing power through a spontaneous reaction, they take in energy to run a non-spontaneous reaction with the cathode receiving electrons and the anode giving off electrons in the same way as the galvanic cell, but now you have the salt in the electrolyte solution go separating towards the anode and the cathode with the positive charged ions of the salt going to the cathode, since the cathode's receiving electrons and becoming negative, while the negatively charged ions are going to the anode because the anode's becoming positive, donating electrons. So yeah, that's all that's about to it, to electrochemistry and the cells. Thank you for watching.